So 8.3, when we are approaching infinity, I make my table slightly different. When we were doing the other, like just add a number, I always made a horizontal table because I can see coming in from the left and coming in from the right my values. But as I approach infinity, I tend to make a vertical table instead, because I can only come in on one side of infinity. So as I'm approaching positive infinity, I'm going to use numbers like 10, 100, and 1,000. And you could argue that those aren't very big, and you're right, they're not. You know, infinity is so enormous, we can't even grasp our head around how big infinity is. But typically, 1,000 is big enough for what we're looking at. We can start to see the pattern. If you need to do more, I put a ... here because if I need to do more, I would try 10,000, 100,000, a million in order to find the pattern. But usually I can get a really good idea of the pattern just by looking at how it's changing as I approach 10, 100, and 1,000. And likewise, if I'm approaching negative infinity, I would do a similar table other than I just changed those to negatives. That's 1,000 here. And again, if I needed more, I would plug in a few more, ... Okay? So we're going to evaluate limits. I would like you guys to get your calculators out and help me evaluate. We'll share the jobs here. Just kind of give it a try, and we'll do some shout outs. What you do have to be careful of when you're doing these is that your top has to be in parentheses and your bottom has to be in parentheses. And if you're squaring something, whatever it is you're squaring also has to be in parentheses, especially if it's a negative value. So you really, this is like user beware. Make sure you're using your calculator appropriately. Because I'm approaching positive infinity here, when I make my table, I'm going to just use, like I did in the past, or in the previous example up here, positive infinity, I'm going to use 10, 100, and 1,000. So I'd like to have, again, you guys just plug those in and see if you get answers, and then we'll compare the answers that we get. I'm going to pause the video and then we'll fill that in when everybody's done. So these should be our values that you get when you plug those in. Again, be very careful with how you plug them into your computer, but these should be what you're looking at. And what you want to do when you're trying to find a limit as x is approaching infinity is you want to see if you can see a pattern of change. And I noticed that from the first value, I had 0.081, but to the next one, I added another 0 after the decimal point, and then snuck a 9 in there, and then I have some 8s and 0s and 1s, but this is like really what's important. Because when I go down to the next one, I notice I have another 0 stuck in there, and I still see that 9. So what I envision happening is next it would be, if I plugged in 10,000, it would probably be 0.00009. And as I keep adding zeros, I'm going to keep adding zeros after my decimal point. So this pattern looks to me like it's approaching 0. So I would say the limit as x approaches infinity of this function is 0. That's what it appears to me is happening. And remember, when you're doing a limit, that's all you're doing. You're finding what what appears to be happening. And so sometimes you have to take your best kind of educated guess, especially when you're working with a table. Sometimes it's not very obvious. And we're going to work on ways to find the precision. But right now, it looks to me like it's going to eventually, because 1,000, again, is nowhere near infinity. If I made this closer to infinity by adding more zeros after my 1, I'm going to add more zeros after the decimal point. And pretty soon, on your calculator won't even be able to take the 9, 8 stuff that comes at the end. It'll end up being 0.000000000, which really is 0, okay? So let's do the same thing with the next one, but this time we're going to approach negative infinity. So when we approach negative infinity, the only thing that changes is I plug in negative 10, negative 100, negative 1,000. Please, again, make sure when you're plugging this in that you square the negative. If this were on the top or on the bottom of a fraction, I would also have to put an additional set of parentheses around it too to evaluate. So again, I'm going to pause and let you guys plug in, and then we'll get our answers and we'll take a look and read our limit, okay? So again, here we have our values: 83, 803, 998,003. What does it look like is happening to these values? Can you envision if you put in negative 10,000, negative 100,000, negative 1,000,000? These numbers are getting bigger and bigger and very, very quickly bigger, right? So I would say this one is approaching positive infinity. So the limit as x approaches infinity of this function is infinity itself. Now technically, if we have it approaching infinity, we say it does not exist. But for what we're working on today, I want to keep it as an infinity value, because we might approach positive infinity and we might approach negative infinity, and so both of those are going to tell us different things, all right? Again, technically it's not going to a particular place, but it is, so it really does not exist, but it is getting bigger and bigger and bigger in the positive side, so we'll call it positive infinity. Okay, so one last one. Again, we have a table. This is another approaching positive infinity, so 10, 100, 1,000. So I want you guys to do it again. Plug it in. Please make sure that when you put your values on here that you put parentheses around the top and parentheses around the bottom. It's all positive numbers, so I don't have to worry too much about that, but we'll get our values, and then we'll take a look and see if we can predict the limit. Hopefully you got values that kind of look like this. Did it work out for you? 1.8, 1.98, 1.998. Again, I can see this, a 9, because I'm very, very organized. I'm using numbers. I can use any numbers I want here that get bigger and bigger and bigger, but because I keep them very kind of organized like this, 10, 100, 1,000, 10,000, 100,000, 1,000,000 that I would check in, I can see a really clear pattern, and it appears to me that it's going to be 1.999999999, or I could say the limit as x approaches infinity of this function is about 2. Okay? So what I want to do now is just get some practice on doing limits as x approaches infinity. There are quite a few problems on the next connecting pages, and obviously I'm not going to have you do them all, but I am going to divvy up. If you're at home watching this, just pick a few of them and do it, and then we'll go over the answers shortly, okay? So for problem number 1, I got 0. For number 2, I got 1. 3, I got infinity. For 4, I got 0. 5, 0. 6 is 1/3. 7 is 0. 8 is negative infinity. 9 is 0. 10 is positive infinity. Again, fill in all the correct answers. 11 is 2. 12 is infinity. Oh, I take that back. 11 is negative 2. Please change that to negative 2. 11 is negative 2. 12 is, like I said, infinity. 13 infinity. 14 negative infinity. 15 is 3. 16 negative 2/7. 17 is 12. 18 is negative 1. 19 is 0. And 20 is infinity. How'd you guys do on the ones that you did? Okay? Pretty good? Okay, good, good. So again, get those answers in, and now I want you to take a look at all of those answers. I want you to just take a few moments, and I want you to try and categorize the types of answers that we got. I'm looking for 3 categories that we could put each answer under. And remember, a category could have to do with the type of number it is, whether it's a positive or a negative number, how big the number is, how small the number is, any kind of category. I want you guys to see if you can pick 3 good categories for these numbers. I'm going to pause and let you do that, and then we'll regroup on our next page. So in our categories, again, anything. Did anybody find one category that seemed reasonable? Like, what were a lot of the numbers? Infinities, you said? Yeah, that's great. So plus or minus infinity would be a great category. Now, if it's not infinity, it has to be some other number. And so now I want to break all of the other numbers down into categories. What's another one that stood out that we saw a lot of? 0. That would be another category. So positive and negative infinity and 0. So if I only had one category left, what would the last category be? Could we just say everything else? Yeah. So that's all other values. That would be everything else would be that last category. Okay? Well, it turns out that these 3 categories are going to show up time and again when it comes to taking limits as x approaches infinity. But these 3 categories they're only consistently going to show up as x approaches infinity. When we do other values, like when we take limits to other values, to 3 or 4 or 10 or 100 or negative number or 0 even, the patterns don't hold. These patterns will only hold as x approaches infinity. And so our 3 categories can be broken down into top-heavy, bottom-heavy, and neutral. When I talk about top-heavy, I mean the power on the top, the highest power on the top is bigger than the highest power on the bottom. The highest power on top is greater than the highest power on the bottom. And when it's top heavy, and when this comes into the case, that's when we're going to get a plus or minus infinity for our answer. So top heavy gives us the plus or minus infinity category. Bottom heavy, the highest power on the bottom is greater than the highest power on top. And that's when we get a zero limit. And then all other answers happen when it's neutral. That means the highest power is the same on the top and bottom. And then we'll get some non-zero number. So top heavy, bottom heavy, neutral. Here's how it works, and here's why it works. We're going to run through a few examples. So top heavy. Number 4 is an example of top heavy. The power, highest power on top, actually it's the only power on top, is higher than the highest power on the bottom. I really only care about the lead terms when I'm approaching infinity. The lead terms are the highest power on the top and the highest power on the bottom. Because when I'm putting in a number that is so enormously large, pretty soon nothing else matters. The highest powers are going to take over. So really what I'm doing is I'm looking at the limit as x approaches infinity of x squared over 2x. The plus 2 doesn't matter. So I can knock it out, I can ignore it. I only want to look at the highest powers. Well, really, this is the same as looking at the limit as x approaches infinity of x over 2, because I can reduce what I'm looking at here. So this is me putting in some very, very large number over 2. Now, obviously, I can't put infinity in my calculator and figure that out. But if you plug it into your table, you'll recognize that I'm going to get a bigger number divided by 2 and a bigger number divided by 2. And if I put in the biggest number that I can think of, it's still going to be a very big number. And so, therefore, for this particular problem, I am going to be approaching infinity. Likewise, here I have a neutral scenario. When I start to clean this up, this becomes the limit as x approaches infinity of x squared over x squared, which then is the limit as x approaches infinity of 1. And when you were watching your video for the last section, if we have a constant, I have no place to put my x in, then my limit will be that constant value. So I'm going to get a limit as x approaches 1. Well, really, when it's the highest power, it's some non-zero number. What we'll end up doing is sort of canceling it out and coming up with a constant. It's not always going to be 1. As we saw, we had problems that were 1/3, one that was -2/7. In fact, I'm going to pull out the one that was -2/7. On your sheet, it was problem number 16. So if I look at the highest powers and get rid of everything else, I'm looking at -2x squared over 7x squared. The x squareds cancel out. I'm left with -2/7. Okay? So you pull out Everything else but the lead terms, reduce it down, you'll get your constant. The last case scenario is bottom heavy. So when I'm looking at that, remember nothing else matters. Infinity overpowers all. So the highest powers are going to be the ones that take over everything. This is the limit as x approaches infinity of negative x over x squared, which is the limit as x approaches infinity of negative 1 over x. It doesn't matter that this is a negative 1, because if I think about what's happening, negative 1/10, negative 1/100th, negative 1/1000th. This is negative 0.1, negative 0.01, negative 0.001. You can see as I continue this pattern and we get bigger and bigger and bigger, I'm going to get closer and closer and closer to 0 on the negative side, but I'm still approaching 0. Okay? So I'm going to have you guys help me out with the last ones. We have 3. You tell me, do I have a top heavy, a bottom heavy, or a neutral? Top heavy. I'm looking at really the limit as x approaches negative infinity of x squared over 4 when all is said and done. Do you get what I did there? I took the x to the 4th over 4x squared and I reduced it down, so I'm really looking at x squared over 4. So what am I doing? I'm putting in a super large negative number and squaring it and then dividing it by 4. What am I going to end up with? A really large, what kind of number? What do I get when I square a negative? Positive. So I'm going to get a really large positive number. Remember, nothing else matters but the lead terms. This only works when I approach infinity. It won't work for other numbers. So what do I have in the next one? Top heavy, bottom heavy, neutral. Bottom heavy. This one is the limit as x approaches negative infinity of 10 over x squared. So I'm going to start putting in really large numbers on the bottom and squaring them. This one's going to, well, I can just go directly to it, equals 0. Because all of a sudden the denominator is going to get so large. 10 divided by 100, 10 divided by 1,000, 10 divided by 1,000,000, 10 divided by 1,000,000,000. Plug it in your calculator. It's going to be a very, very, very small number close to 0. And then my last one is obviously neutral. So I'm going to be looking at the limit as x approaches negative infinity of 2/5, constant value, 2/5 is my answer. So that's how our limits as x approaches infinity works. A lot of people ask about, well, what if it's approaching positive infinity or negative infinity? Truthfully, the only time you need to think about it is when you are top heavy. If my answer is going to be positive infinity or negative infinity, it's going to depend on what am I left with and what am I plugging in. So I'll have to think about that and be a little bit careful with that. All right? So your assignment is 8-3 evens or odds. And like I said, on A day, you will take your test on Friday. If you're a B day person, you'll take your test on Monday. It'll be an in-class test.